I'm so happy to have you back. You're welcome. Good. So we continue with current electricity, and under this we'll be talking about the arrangement of resistors in parallel form. If you have a parallel arrangement of resistors, how do you calculate them? There are some things you need to understand, not like I've said in the previous video for series arrangement. For parallel arrangement, don't forget, let me recap. For series arrangement, you have the same current flowing through each of the resistors, where you have different potential difference across each resistor. And the potential difference flowing or in a resistor depends on the amount or the value or the magnitude of that resistor. The reverse is what we have in parallel arrangement. In parallel arrangement, we do not have the same current flow through them. Of course, we can have a combined current in the whole circuit, but each of the resistors does not have the same current flow through them. That implies that the current in let me just use my normal I. The current in this the current here will be equal to I1 plus I2 plus I3 plus on and on to current to the nth current. While the potential difference will be equal to P1, and that is equal to potential difference 2 equal to potential difference 3 all along till you get to what? To the nth potential difference. So which means the potential difference across the resistors are the same thing, unlike that of series arrangement. So we have them differ that way, but we'll go to the calculations concerning that in other video. But now let's talk about how do we calculate the what? You said the total resistance measured at PQ. We have two questions here. This point P, it went this way, stop there. And here we have this came from here, it came from here and went this way and went this way, then stopped here. So what do we have? The first thing you do is what? You calculate for, let's do for this first. So what do we have? So what do we do? We have I think I mentioned, okay, I've not mentioned, sorry. The combined resistance for parallel arrangement, okay, let me call it should be 1 over 1 upon R will be equals to 1 over R1 plus 1 over R2 plus 1 over R3 plus on and on to 1 over R subscript n. So that's what you will have. Then when you are now done, don't forget this is what we are looking for. You are not looking for 1 over R, you are looking for this combined resistance. But this is a formula for calculating the combined resistance in a circle such that the resistors are arranged in parallel. So here, what happens? Our question 1, I mean this will go. Then what what do we have? We're going to be having 1 upon 3 plus 1 upon 2 plus 1 upon 6. So you can find the LCM. Of course, that is 3 in 6, 2 times 1, that is 2 plus 2 in 6, 3 times 1, you have 3, 6 in 6, 1 times 1, that is 1, and there all in all we have what? 6 upon 6, and that is 1. So what does that mean? That means that our this is equal to 1 over 1, and that means 1. So automatically our combined resistance will be 1 ohms. Do you get that? Don't forget, resistors is measured in ohms, current in amperes, then the voltage is in potential difference. Potential difference is measured in volts. So just a quick reminder on that. So let's go on to question 2. In question 2, you have something a bit different, which are the likely questions you will see in your exams. So we will not see this one that we have done because it's very much cheaper. So we have this. Yeah, how do we go? If you look at this place, if you stretch this place, these two, you must learn to study the pattern when you have a circuit with resistors. Yeah, we can write these 3 resistors like this. We can place them on a straight from. We have 2 ohms, 2 ohms, 2 ohms. So what does that mean? They are in series. So we can have it and say the combined resistance for them will be 2 plus 2 plus 2, and that will be equal to 6 ohms. Isn't it? So since you now have them in 6 ohms, what do? We will remodify this question. We'll remodify it. So what do we have? Permit me to do this. We have to remodify this. Remodify this. Then you have what? This will come this way. This will come this way. And you have this. Don't forget 1 ohms is here. So here 6 ohms will be here. Can you see that we have remodified the whole shape, the whole circuit? So here, look at these 2. How are these 2? These 2 are not in series, they are in parallel. Look at it from this way, just like the one we did the other time. Add something like this, add something like this, add something here, add something here, then add something here. You see that this is parallel. So the same thing, this one is just tilted, so you have it also parallel. So you have that to be parallel. So what do? It means I can write my combined resistance to be going to be having 1 over R is equals to 1 over 1 plus 1 over 6. Another formula or a shorter method for that is to just do what? Since there are 2 resistors that are in parallel arrangement, we can just, if you make R subject to formula A, you can say R is equal to, you have this R1 times R2 upon R1 plus R2, and that means what? 1 times 6 upon 1 plus 6. So what do we have? We definitely be having 1 upon 7. So we have 1 over R equals to 6 upon 7, and that will be what? Divide this 0.60, 56 times 8 mean the 4. In 40 you have 5, mean the 5. In 50 you have 7, mean the 1. Add 0, you have a 1. So we can have it stop here. So we have this to be this ohms. So we modify this again. If you remodify this, this will go, 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 this itself will go. Then you're going to be having what is 0. You have 0.857 ohms. What kind of arrangement do we have? Finally, it is a what? A series arrangement, just like the first one that we did. So we have series arrangement here. So having gotten series arrangement, what do? Just add them, then the final resistance, combined resistance will be equal to what? So you're going to be having your R equals to 1 plus 0.857 and plus 2, plus 1, 2. So that becomes 2.857 ohms is a combined resistance in the whole circuit that we did. If you have any question, you're free to reach me on my contact. You can reach me via 08164869477. Of course, plus 234 is a Nigerian contact. Thank you. Reach me or you make your comments known in the section for comments. Thank you and have a great learning time.